All right, continuing on with geometric sequences, right? This is a question where you're asked to solve for the n value. So let's just write down some information here. Our first term of the sequence is 32. I can figure out my common ratio, which is 2. My last term of the sequence would be, but I don't know the n value of that, is 16,384. And my n value is an unknown. This is what I want to solve for. Okay, so I'm going to substitute everything into my formula that I know. My general term, or my last term, would be 16,384. My first term would be 32. My common ratio is 2. And then I need to solve for my n value. Okay. Well, in order to solve for your n value, right, this is a spin-off from those common bases. The first thing we're going to do is we're going to isolate this base here. So we're going to move this 32 to the other side of the equation by dividing both sides by 32. And I get a value of 512. Now, in order to solve for n algebraically, what we want to do is on both sides of our equation, we want to get a common base. So this has a base of 2. I want to change this 512 to a base of 2 as well. So remember, it's a guess and check game. You're literally just trying 2 to some power until you figure out what that power is to get 512. And it works out as 2 to the power of 9. So now that these have common bases, I can ignore my bases and simply solve this exponential equation. So 9 is equal to n minus 1. Add 1 to both sides, n would be 10. Therefore, the number of terms in the sequence would be 10 terms. Or the other way to think of this is this value here is the t of 10, the 10th term.